Students, we have this question for a real number alpha, beta, gamma and delta. If we are given integral x squared negative 1 positive tan inverse of x squared positive 1 divided by x times dx divided by x to the power of 4 positive 3 times x squared positive 1 times tan inverse of x squared positive 1 divided by x is equal to alpha times ln of tan inverse of x squared positive 1 over x plus beta times tan inverse of gamma of x squared negative 1 divided by x plus delta times tan inverse of x squared positive 1 over x, positive arbitrary constant c. Then find the value of 10 times of alpha, beta, gamma plus delta. You got to get this value. Okay, so this is a question. You can pause the video and look into the question. Okay, so let me start. I hope you all have got the answer. If not, you can just check the workout. So first, what I would do is I would just consider integral x squared negative 1 positive tan inverse of x squared positive 1 over x times dx divided by x to the power of 4 positive 3x squared positive 1 times tan inverse of x squared positive 1 over x. Now if you have a positive b divided by c, you can rewrite it as a over c positive b over c. So this is equal to integral x squared negative 1 times dx divided by x to the power of 4 positive 3x squared positive 1 times the tan inverse of x squared positive 1 divided by x. This is one component plus integral tan inverse of x squared positive 1 over x divided by x to the power of 4 positive 3x squared positive 1 times tan inverse of x squared positive 1 divided by x times dx. Now I can take this as I1 and I2 is equal to I. Okay, so now what I will do is I will consider I1 to be equal to integral x squared negative x squared negative 1 times dx divided by x to the power of 4 positive 3x squared positive 1 times the tan inverse of x squared positive 1 divided by x. So now what I wish to do is I will make the substitution. Let tan inverse of x squared positive 1 over x be equal to some t. So move this t to the, or I would say move tan inverse to the other side. So you get x squared positive 1 over x is equal to tan t. Now you differentiate both sides. So this is a u over v formula, right? Differentiation of u over v is v times u dash minus u times v dash divided by v squared. So if you were to differentiate it in this fashion, x times of differential of x squared positive 1 is 2 times of x negative. This is x squared positive 1 times the differentiation of the denominator will give me 1 divided by x squared. So this is going to be 2 times of x squared negative 1 divided by x squared. You add 2x squared with negative x squared, you get x squared negative 1 divided by x squared. So differentiating, this is what you get times, we need to place the dx there. So let me write that down. X squared negative 1 divided by x squared times dx is the differentiation of this. Now differentiation of tan t is secant squared t times dt. So what I will do is I will have to go back, or I would say go to the next page. So let me use this side. So I have x squared negative 1 divided by x squared times dx is equal to secant squared t times dt. Right? That is what I have got. Let me check it again. Okay, it's correct. Now what I would do is I will have to use this formula. Secant squared negative tan squared t is equal to some 1. So from here secant squared t is equal to 1 positive tan squared t. Now we have one substitution. What is the substitution? Tan t is equal to x squared positive 1 over x. Tan t is equal to x squared positive 1 over x. This is for tan t, right? So this would mean my secant squared t is equal to 1 positive x squared positive 1 over x the whole squared, right? So what I wish to do is in place of secant squared t I will place this one. So therefore x squared negative 1 over x times dx is equal to, let me write that down, x squared positive 1 raised to the power of 2 divided by, this entire thing is squared, right? So I will write it as squared like this, times dt. Okay, so this is what we have got. This is x squared minus 1 divided by x squared. So if I were to rewrite this with dt on one side and bring everything of x on the other side, then I would have x squared negative 1 divided by, now this x squared gets cancelled. You have a dx there and you bring this x squared positive 1 whole square is equal to dt. Now you expand this, you get x squared negative 1. This is x to the power of 4 positive 2 times x squared positive 1. So this is what you have got. But there is one important thing we have missed. What is that? We did not add this 1 here. So there is a 1 over there, but we did not add, we directly cancelled it out. So what I am going to do is I will rewrite this with the LCM x squared. So it's going to be x squared positive 1 the whole squared. So of course they get cancelled, but when it comes down, when this comes down, there is an x squared there, right? So that would mean you have now a 3x squared times the dx is equal to dt. So let me rewrite it again. So this means x squared negative 1 over x to the power of 4 positive 3 times x squared positive 1 times the dx is equal to dt. Okay, so let me go back to the question. So this is our I1, right? So I need to write this I1. So hence I1 is equal to integral x squared negative 1 times the dx divided by x to the power of 4 positive 3x squared positive 1, that is one component, times tan inverse of x squared positive 1 positive 1 over x. So this was the I1 that we have taken. Now clearly if you can see here, x squared negative 1 times dx divided by x to the power of 4 positive 3x squared positive 1. This is nothing but my dt. Right, so you substitute that. Now this tan inverse of x squared positive 1 over x is nothing but my t. So substitute that. and you integrate that, you get ln of t. But what is my t? What is this t? This t is tan inverse of x squared plus 1x. So which is equal to ln of, probably you can place a modulus sign, tan inverse of x squared positive 1 over x, positive arbitrary constant. So therefore I1 is equal to ln modulus tan inverse of x squared positive 1 over x, positive arbitrary constancy. So this is the evaluation for I1. Go back to the evaluation of I2. Now what is I2? I2 is tan inverse of x squared positive 1 over x times dx divided by x to the power of 4 positive 3x squared positive 1, right, times tan inverse of x squared positive 1 over x. This is what's our I2. Now clearly this and this gets cancelled, giving me integral dx over x to the power of 4 positive 3x squared positive 1. Now what I wish to do, I will multiply the numerator with 2 and I divide it by 2. So this is x to the power of 4 positive 3x squared positive 1. Next, what I wish to do, I want to rewrite this 2. Okay, so I want to rewrite this 2 in such a fashion that I have x squared, but I am actually getting rid of that x squared also. So I need to have a 1 there. This can be positive x squared and negative x squared. So 1 added with 1 will give me 2. X squared added with the negative x squared, they get neutralized. So 2 will return like this. Next, I'm going one step further. I'm going to rewrite this as 1 positive x squared. I'm going to take the negative sign out and rewrite this as x squared negative 1. Okay, negative times x squared will give me negative x squared, negative times negative 1 will give me positive 1. So it's the same 2. So this is equal to half times integral 1 positive x squared negative of x squared negative 1 times dx divided by x to the power of 4 positive 3x squared positive 1. Now this can be rewritten as half times integral 1 positive x squared times dx divided by x to the power of 4 positive 3x squared positive 1 negative x squared negative 1 times dx divided by x to the power of 4 positive 3x squared positive 1. Now what you do is you consider this component. I'm just going to be considering integral 1 positive x squared divided by x to the power of 4 positive 3x squared positive 1 times dx. I will divide by x squared, the numerator and denominator. So this would mean I have a 1 over x squared and a 1 divided by x squared plus, I want to actually get rid of this x squared holding on to 3, because this will actually pose some challenges for us. So that's the reason. So 3 positive 1 over x squared times dx. Now I want to convert this into a perfect square. So what I wish to do is I need to have a 3x negative 1 over x. Let me have x negative 1 over x. You might be asking me why. Because when I differentiate negative 1 over x, I clearly get positive 1 over x. That's the reason I want to have negative 1 over x. Now if I were to expand this, I would get an x squared positive 1 over x squared. Fair enough. X squared is there, positive 1 over x squared is there. But when you bring in the middle component, negative 2 times ab, you get a negative 2 there. So I need to ensure that I get a positive 3 there. So for that I need to add a positive 5. So we need to do all this. So this is equal to integral, I'm going to write this as 1 positive 1 over x squared times dx divided by, this is going to be x negative 1 over x raised to the power of 2 positive 5. Okay, fair enough. Now let me make the following substitution. Let x negative 1 over x be equal to t. You differentiate this, you get 1. You differentiate this, you get 1 over x squared times dx. You differentiate t, you get dt. So clearly that's exactly what you got here. So with this differentiation, this is going to be equal to dt divided by, this is t squared positive 5. Now I can rewrite this as the dt over t squared positive root of 5 the whole squared. Now what is this? This is nothing but 1 over a tan inverse of t over a root 5. But what is t? We have to go back to our substitution of our t, right, which is x negative 1 over x. So it's going to be 1 over root 5 tan inverse of x negative 1 over x divided by root 5. Now we need to bring it in the form of the problem. Let me show you the problem. The problem has got tan inverse of x squared positive 1 over x. Right. So we need to bring that over here. So if we were to bring that, this would give me 1 over root 5 tan inverse of x squared negative 1 divided by x. So I have x there, but what I need to do is I will have to write that as root of 5 into x. You can further rewrite this in this fashion. How can you further rewrite this? You can rewrite this as 1 over root 5 tan inverse of x squared negative 1 divided by x times 1 over root 5. Now you might be asking me, why am I writing it like this? What is the reason? Now you see here, do you see what I see? See there, gamma times x squared negative 1 over x. This is gamma times x squared negative 1 over x, and you have 1 over root 5. What is 1 over root 5? That's going to be the beta value. So what we have done, we have got the beta value 1 over root 5, and we have got the gamma value, which is also 1 over root 5. Right? Well, I think you can safely write it as 1 over root 5. Okay. So this is what you have got. Now, having got this, what we need to do is we will have to go and solve the next part. Now you have the next part over here, so we need to solve the next part. So just give me, I'm just going through this, I'm just looking for the gamma value and the beta value. Okay, fair enough. I think we'll proceed. So now we will go and we will consider this component. So now there is one more thing we need to take it into account. What is that? You have 1 over 2. That's the reason I was paying attention a little bit extensively. You have this 1 over 2 coming here. So when that 1 over 2 comes here, our component of beta will change. Why? Because we have just considered this, right? So if we were to multiply by 1 over 2, so this will become 2 times root of 5. There won't be any effect. There won't be any effect on this. Okay, there won't be any effect of this. So let me just write the final thing. So therefore, half times of integral 1 positive x squared times x divided by x to the power of 4 positive 3 times x squared positive 1 is equal to half times of integrated value is this 1 over root 5 tan inverse of x squared negative 1 divided by root of 5 times x. Okay, this is going to be 1 over 2 times root 5 tan inverse of x squared negative 1 over root of 5 times x. Of course, I wrote it like this, 2 times 1 over 2 times root 5 tan inverse of x squared negative 1 over x. This is one component multiplied with root of 5. This is a y root. So therefore the value of beta is going to be 1 over 2 times root 5. The value of gamma is 1 over root 5. Okay. Now let me consider the next part. Consider 1 over 2 integral x squared negative 1 times the dx divided by x to the power of 4 positive 3 times x squared positive 1. So this is what we have got. Now as I mentioned to you, I will divide by x squared the numerator and the denominator. So that in turn would give me 1 over 2 integral 1 negative 1 over x squared divided by x squared positive 3 positive 1 over x squared times the dx. Now I need to make a substitution in such a fashion that when I take it equal to t, I differentiate, I'm able to get the numerator. So for that I need to get a 1 and a negative 1 over x. So I want to rewrite x squared positive 1 over x squared positive 3 as x negative 1 over x the whole squared, because differential of x will give me 1. Differentiation, I should write it as positive. Differentiation of 1 over x will give me negative 1 over x squared. That's what we have got. But we will get extra 2. So to compensate that, so that we can get a 3 there, I am adding a 1 there. So this is going to be equal to half times integral 1 negative 1 over x times dx divided by x positive 1 over x the whole squared positive 1. Now let me take x positive 1 over x to be equal to t. I differentiate, I get 1. This is negative x squared. I differentiate, I get 1 negative 1 over x squared times dx is equal to dt. This is half times integral. This is going to be dt. This is going to be t. You have a squared there and you got a 1. Now this upon integration would give me 1 over a, that's 1 there, tan inverse of t. Now this can be further rewritten as half times tan inverse of my t is x positive 1 over x, x positive 1 over x. Now you take the LCM, you get tan inverse of x squared positive 1 divided by x. So this is what you've got. Now the problem. So let me go to the next page. So therefore, see, this has been the original question, right? Or I would say part of the question. So we actually took this as the two components. Okay. So therefore, half times the integral 1 positive x squared times dx divided by x to the power of 4 positive 3x squared positive 1 negative half times the integral x squared negative 1 times dx divided by x to the power of 4 positive 3 times x squared positive 1. Now this has been found to be this. Okay, isn't it? So let me rewrite that. So this is equal to 1 over 2 times root of 5 tan inverse of 1 over root 5 of x squared negative 1 divided by x. This is the first part, followed by the second part. The second part is going to be 1 over 2 times tan inverse of x squared positive 1 divided by x. Now we should go back to the question. The question we actually solved, right, for I1. No, we already solved for I1. I1 is this. So therefore I is equal to I1 plus I2 will be equal to ln modulus tan inverse of x squared positive 1 over x. This is one component, followed by second component 2 times the root of 5 tan inverse of 1 over root 5 of x squared negative 1 over x, followed by negative 1 over 2 tan inverse of x squared positive 1 over x. Now we need to go back and compare it to the question. See, what is the question here? Alpha times, we need an alpha here. So what is alpha? Comparing, we get alpha to be equal to 1. Now beta, we already got the value of beta. Beta is 1 over 2 times root 5. Now gamma is 1 over root 5. Now we need to have a delta. Let me show you that. Now delta is needed. So delta is going to be, we need to get a positive of this. So delta will be negative 1 over 2. Right. Of course I will place an arbitrary constant c. So we need to find out this. So therefore 10 times of alpha plus beta gamma plus delta is equal to 10 times of alpha is 1, beta is 1 over 2 into root 5, gamma is 1 over root 5, delta is negative 1 over 2. You add these two together, you get 1 over 2, and this one is going to be 5 times of 2. This is going to be 10 times of 1 over 2 positive 10, which is going to be 10 times of, you take the LCM as 10, 2 divides 10 5 times, 10 divides 10 1 time. So 10 times of 5 added with 1 is 6 divided by 10. 10 gets cancelled, giving you 6. So that's the solution for this question. Thank you.